Hello mga ka-tribes! Welcome to Daddy Brew TV. And this is your adventurous math teacher. For today's video, let's talk about the T distribution. Now, look at the given diagram. The T distribution, just like the standard normal curve, it is bell-shaped and unimodal. It is symmetric about t equal to 0. However, its variance is greater than 1. This makes it wider and flatter in the middle. It has more area in its tails than that of a standard normal curve. Its shape depends on the sample size n. As the sample size n becomes larger, the t distribution gets closer to the standard normal distribution. Statistical analysis on some studies which cannot be done using the normal distribution can be done using the t distribution. The t distribution is used with small samples taken from population that is approximately normal. Okay, what is the formula of the t distribution? So for our formula, t is equal to the sample mean minus mu divided by s over the square root of n, where x bar is equal to the sample mean, mu is equal to the population mean, s is the standard deviation of the sample mean, and n is equal to the sample size. The z statistic in the previous lessons uses the value of the population variance, while the t statistic uses the sample deviation, especially when the population variance is unknown. Take note, the population variance here is unknown. The z statistic is used when n is greater than or equal to 30, while the t statistic is used when n is less than 30. To find a value in the table of t critical values, there is a need to adjust the sample size n by converting it to degrees of freedom, or df. The formula for degrees of freedom, or df, is equal to df is equal to n minus 1, where df is the degrees of freedom and n is the sample size. So degrees of freedom is equal to n minus 1. Take note. Let's have example 1. A student researcher wants to determine whether the mean score in mathematics of the 25 students in grade 8 section Newton is significantly different from the average of the school, which is 89. The mean and the standard deviation of the scores of the students in section Newton are 5 and 15 respectively. Assume a 95% confidence level. Okay, for our solution, let's have step 1. First, find the degrees of freedom, denoted by the formula n minus 1. So our n is 25 minus 1, that is now 24. Therefore, our degrees of freedom is 24. Step 2, find the critical value. Use the table of t critical values. Okay, since the confidence level is 95%, again, we will use the formula 1 minus alpha times 100% is equal to 95%. Solving for alpha, we have 1 minus alpha is equal now to 0.95 and alpha now is 0.05. Dividing alpha by 2, we have 0.025. Okay, why we divide? Because we consider here two tails. To find the critical value, look at 24 under the column headed degrees of freedom. Here. Move to the right along the row until reaching the column headed 0.05. 0.05 area in 2 tails or 0.025 for area in 1 tail. The critical value now is 2.064. Okay? Now, for step 3, compute the test statistic T. So, using now our T formula, that is now equal to the sample mean minus mu over S over the square root of N. Replacing the sample mean, we have 95 minus the population mean, 89, over S, 15 over the square root of 25, and the result is 2. Okay. The computed value of T is equal to 2, which is smaller than the T critical value of 2.064. Our critical region is to the right of 2.064. The computed t-score is 2. Now, what does it mean? Let us interpret. It means the value of the test statistic or computed t-value does not fall in the critical region. Therefore, the mean score of grade 8 section Newton in mathematics is the same with mean score of all the students taking up grade 8 mathematics. Okay? So much for this. Thank you for watching. Follow for more. Bye.